So here's the outline. We're going to talk about strong versus weak variables, blocks, and closures. So this talk is going to be a little bit of Objective-C and a little bit of Swift. I'm still doing the transition process right now, so I know a little bit of both, but so it's kind of one of those things where I was very reluctant to go into Swift like right away, but now I'm enjoying it, and so it's a lot of fun. I'm going to talk also a little bit about capture list in Swift, which I know a tiny bit about. Private versus public, singleton models, and memory management. We're going to walk through the instruments tools. I'm just going to kind of give you an outline of how to use the tools I use basically for debugging and profiling code. We're going to talk a little bit about collection classes, and then also a little bit about NSObject and swizzling objects. Okay. So let's go through a little bit of vocabulary here. In my day, when I was learning Objective-C, we were using the term methods to refer to functions. So, so when I'm talking, I'm going to be when I say methods, I'm really talking Objective-C terms, and if I say functions, I'm going to be talking Swift terms. So, I try to use a difference in the different verbiage for different languages, just because that's vernacular, I guess. Also, NS array, NS dictionary, NS whatever, that's Objective-C. Blocks, that's an Objective-C thing for creating closure type stuff. And then square brackets, that kind of stuff. Curly brackets, semicolons. Those are the kind of terms I'm going to be using in the Objective-C vocabulary. For the Swift vocabulary, I'm going to be using functions, array, dictionary, string, closures, tuples, generics, and then let. All right. So what is coding zero to coding hero? The idea is the KISS, right? I think everyone's seen, gonna keep it simple, right? I always think, like every time I hear somebody say stupid, I'm always thinking like, oh man, they must be talking about me, right? I had a professor in computer science. He was always talking about. He always had this one lecture. I mean, the first lecture, he said. It was really disturbing. In the first lecture in the class, right, he says, there's no such thing as a dumb question. There's just dumb people that ask questions. I was like, okay. Whoa. So I'm changing it to short and specific. So the idea, of being a better coder is all about simplifying things and making things so that your objects are specific to the functions that they need to be working on. So that's the concept. Also, our goal is to write less code. I keep that as my mantra for any language, regardless of C, Objective-C, I don't know, web, HTML. The less code I write, the better I'm off. The less, less hair pulling after that. So the question is how? Well, abstraction. So abstraction is kind of the idea of basically saying, if you want to take something that's basically a unique concept, and you want to say, how do I want to interact with that? How do I want to talk to that? Well, then you kind of create an abstraction, because you want to basically say, I want to talk to it with this call, and this call, and this call, and have it return back what I want it to do. So I'll go a little bit more detail on it a little bit later. So, an example from Apple was, this is how it was back before iOS 4, I believe. This is how you were creating animations. I love animations because it always like instant gratification. You're like, ooh, things are flying around on the screen. So our demo is going to have some animations in it, just because I love it. This is kind of the base. This is how UI view animations were set up. You had one line to start the animation, you set a few properties on the animation, you set some curve, and then in the middle somewhere, you actually do the stuff. You manipulate the frame to say, I want to move it from there to there, and then you wrap it in commit animations, and then it would basically say, oh, okay, I'm going to step through all this stuff, and then I'm going to do this manipulation, and then the animation is going to happen behind the scenes, and it's going to go from beginning to end using all these different properties that I had set. So if you have any questions, please let me know. I love getting questions. So if you guys aren't familiar with kind of the animation library, please let me know if you don't understand any of this. But the idea was that Apple later on introduced blocks. So they basically said, okay, well, instead of doing it like this, let's actually do it this way, right? Where we say, let's have one method that you basically call, you pass in the properties you want, and then inside of that, you have a block that says, let's, put in the, set the frame, and then if you want to get a completion, if you want to know when it actually finished, you can actually set a completion block. So before this code, you actually had to set a delegate, and the delegate would call your delegate method, and you would say, oh, okay, yeah, I got this delegate method, now I got to get rid of the delegate and all this stuff. So this is kind of, the idea of how Apple's using, basically abstracting things using blocks. So I just want to also present the Swift version of the same code, just so we're kind of doing apples to apples here. So this is the Swift version. The key thing that I like is that Apple highlights the idea of writing less code, right? So the idea of these little curly brackets here, I never understood those. These little caret things up there, So Apple said, okay, if you're going to write a closure, then basically just say, okay, let's put the parentheses, because okay, parentheses represents functions, right? And then you're going to say this is the output, and it's going to output void, basically. It's going to output nothing. And then inside of that, you actually put in what you're going to do. So it's, that's kind of, I like it because it looks simpler, and then it actually makes it more self-contained. All right, so let's see. I'm gonna skip this example because I want to go through the slides a little bit more. But the idea for what I'm going to do is basically show you a sample project that I did and kind of walk through all the different properties of it. So the next thing is blocks and closures. So this is kind of the definition I got from basically a generic internet basic container for code that acts like a dynamic function and can be executed at some future time. So the idea of blocks is basically, instead of actually creating a function, put that, whatever that function was doing, if it's short, if it's something small, just put it into a little block so it's contained in the context of what you're working with. So the UI view animation is a good example of that. You don't want to have animate frame 1 function and animate frame 2 function, animate frame to 3 function. You can actually say, okay, I'm going to take the view animation and say, okay, I'm going to put it in a closure or block, and then go to the next thing and say, I'm going to create another block and do the animations. And you can create multiple blocks within a single function. So the benefits of blocks is that it reduces code, reduces dependency on delegates, and it's a little bit more contained and more readable. Also, closures is kind of Swift's implementation of blocks, but a little bit better. So this is basically the same example that I gave before. The idea of just basically saying, okay, we're going to take this group of code, turn it into a block, so it's a little bit simpler, and then there's the Swift version of that. I love finding good articles online. So there's a good website called Gosh Darn Block Syntax that really helps for figuring out, like, oh man, how do you draw that? How do you do that syntax for creating blocks as a property or whatever? So, so basically, I've outlined all the stuff that's on the site basically. So, so you can implement blocks as a local variable, and it's basically, it just looks ugly now. I mean, so the idea of closures was to kind of make this just a little bit simpler. But the idea is you have local variables. You can define a block as a property or a method parameter, or you can pass a block as an argument. So you know, I always encourage people to use blocks as much as possible because it actually, it's better than having to do like some type of delegate model where you're basically saying, okay, I'm going to tell this function to do something and then call me back when you're done. This is the closures kind of example. So basically, this is closures as a variable, as optional, as a defined type or type alias, as a constant, and as an argument to a function call. So this is, you know, this is gosh darn closure syntax. So this is their gosh darn block syntax, and gosh darn closure syntax. There's also gosh darn Swift syntax as well, you know, for good reference. So let me show you what the code I have here. So I did this project just to kind of outline just some basic functionality of building an app. So this is the main view controller. I'll just show you what it looks like in the storyboard here. So basically what I did is I have a main view controller that just has a little progress bar. What it's going to do, it's going to load 4 videos. They're basically the same video, but they're being pulled from the web. And then I'm basically going to take those 4 videos, bring it in, and it's just going to show a little progress of them, you know, loading, and then it's going to play the video. So let's see. So I wrote the main view controller. I have 2 main view controllers. One is actually an Objective-C version. The other one's a Swift version. So I like Objective-C, so that's where we'll start. So let me validate this actually. I'm just prepping my camera. I don't know if I actually prepped these videos. So what I actually did was I have a video that was my daughter. She actually likes to sing and dance, so I thought I'd use that as a reference. And what I was doing was there's a little website that basically you can take a YouTube video and get a direct link to it. So let's see if I can log in first. I was going to prep this up beforehand, but no, I forgot the code. So I'm just going to take this link and drop it into my code here. So I kind of put in a little bit of delay for each video just to show like the progress bar, because these videos load so fast that the progress bar goes from 0 to 100. So I added my own delay to kind of show that the progress bar is actually working. So that's me and Olivia, you know, in the house. She's dressed up in her Shirley Temple outfit. And then I have here a button that if you click on it, it'll actually just repeat the animation. just we'll rerun the code. So I'll be posting this up on GitHub after the talk. So the idea, I just wanted to kind of walk through what this is actually doing. So in the start of this code, basically on view will appear. Can you guys see that, or I need to increase the font? Is it okay? It's readable? Okay. So in view will appear, I basically call setup videos. That will basically load my URL and create what I created as a demo player view controller. So I created this view controller just as an example of abstraction. So the idea was basically, I could have just created my own AV player view controller and then created an asset for it and created a player for that and then assigned that to that. But I was like, okay, let's keep it simple. So, I ended up wrapping all that into an object. That subclass is, this is demo player view controller, subclass is AV player view controller. And then I implemented a method called load video URL. And inside of this, I actually set the asset, create a player item, and then have to create a player. So basically all of this code, I could have had that in the main, but I wanted to put it in something where if I needed to create multiple instances of this view player, I didn't have to copy or paste any code. It was all in one class. So the idea is that I can now use this demo player view controller somewhere else in another view if I wanted to, because it's all self-contained that way. I'll tell you a little bit more about the perform block of code a little bit later if we have time, but the idea was I just wanted to show an example of of basically adding categories or extensions to objects. So we'll go through that one later. But anyway, so in Objective-C, I was a big fan of this thing, enumerate objects using block. I was originally, you can create a little for loop and say, for each object, for index I, plus, iterate through your array. And so I created an array and I'm iterating it using enumerate objects, using block. So like I said, I love using blocks. That's what I'm, And then inside here, I instantiate my player view controller. I add it to my array, and then I call load video with URL. And then I also created a completion block so that when the video is finished loading, it'll tell the main view controller, hey, I'm done loading. So then I can actually keep track of which objects have completed, which videos are completed. And then inside of here, I actually call video setup completed, which just updates my progress view. So the progress view is basically I set the progress equal to this completed count divided by the number of objects in the array. So if there's, so start out with 0 and then 1, then 25%, then 50%, and so on, up to 100%. So that's kind of how it works. And let me show you the Swift version. Let's see if I can get it over here. So here's the Swift version of the same code. I tried to do it line by line so you could actually kind of compare. So as far as setting up the videos here, I actually I don't have enumerated with objects anymore. So, but in Swift, you can use tuples. So basically, I iterate through this using enumerate on the array. And then I can use a tuple to access an index and a reference to the object. You guys see that okay? if there's any question, please, shoot, let me know, raise your hand, whatever.
So the two question marks that you have on line 76,
Yes,
is that validating the file path is null, then assign null to full path? The file path is not null, assign path is null.
assign it to path and bundle. Yeah.
Okay. Is that like a short form of?
Yeah, it's a short form. It's basically to do kind of inline validation.
So question mark colon is that the new form of?
That is a new format. I mean, originally, I think you could do something like, if this equals nil, or not equal nil, then you can return back the same thing.
Right. Okay.
You could say file path, bundle path with path and bundle. But the idea is that if you do it this way, it's actually going to call path and bundle twice. So this way it actually validates it. In Objective-C, what I used to do is what I was doing before was doing it this way. So this was basically the same thing in Objective-C, where question mark colon was basically we're saying, okay, if it's not nil, then pass it back, else resolve to the next thing behind the colon. So, but in Swift, it's a little bit different because, just because it's Swift 1, but you're also validating, that it's nil, or maybe some kind of other optional value. I think you could say as NS attributed string or something like that. So, well, I won't go there. I won't go there. But basically it's just kind of a way to do a check in line for is nil, basically. And I created this path and bundle as an extension to NS string. So if I go here to this version, so yeah, this version is basically I have two. This is called a category. And how you implement a category in Objective-C was you say add implementation, the class, and then you give the category a name in parentheses. And so in here, I was basically creating a simple wrapper or an abstraction so that I could take the string object and find its reference inside the bundle. So the idea was that if the URL is local to my file system, then it should be in my bundle. If it's not, then return nil. So the idea was that, okay, if I have an array of objects, one maybe pointing to the server, or maybe one's pointing to local, you can actually use this as an abstraction to say, okay, is it in my bundle? No. If not, do something else, basically. So I'm just using that as a way to abstract it so that I always hate this like NS bundle stuff. It's kind of bloated. The NS file manager has a bunch of methods that's it's also kind of bloated. So I always like to do wrappers around those kind of things, especially like if you're always accessing the documents directory or some temporary files directory, cache directory. I always create some kind of category on NS string or NS file manager to just say, hey, give me the documents directory or something like that. So that's the kind of idea of using categories to help with basically doing better abstraction for objects. I have this other one called URL value. It was just kind of my little sugar I like to add on stuff. Basically, the idea is that a string when a string is accessed from a file, you have to call file URL with path. Or if a string is actually a HTTP link, then you just call URL with string. So the idea here is that when URL with string, when you pass in a file path for this, it actually returns nil. But if you know it's nil, then you say, okay, well, let's resort to trying to get the file path. And if that returns nil, then I just return that back. So the idea is basically, you know, if I want to, it's almost like saying, you know, I just want to get one thing out of it. I want to get the URL value, right? I say I have a string, I want to get the URL value. I want to turn it into an NSURL, regardless of if it's a file URL or if it's a, HTTP URL. So that's kind of, you know, just an example of how to do that. All right, let me go back to the slides here. We will continue on. All right, so strong versus weak. I always had problems dealing with strong versus weak. I used to work at Apple back in 2004, and strong and weak weren't even there back then. It was always like retain, release, auto-released, or, you know, auto-retain, that kind of stuff. So strong and weak were kind of a new concept to me. So if anybody catches me saying something wrong about it, then definitely let me know. But the idea that my typical take on strong versus weak is, strong is when you don't want your object to go away, and weak is when you don't want the object to hold you back. So the idea is basically, if you are having a property that's maybe an outlet, that's probably the most common cases. You have some view inside your main view, and you need to determine whether or not it needs to be strong or weak or whatever. Apple suggests for IB outlets to have them as weak, and which is funny because by default, all of properties, like if you don't specify strong or weak, it defaults to strong, I believe. So but for IB outlets, they actually suggest it's weak because in their context, if it's a subview of some other view, the view is going to have a reference to that object in some array or something. So if it's always going to be a subview of your main view, then you don't really need a strong reference to hold on to it for. That's Apple's explanation. But there are cases where you might have the view, you want the view to disappear, or maybe you want the view to go away for a little bit and then come back when you need it, you know. So, I mean, there's always cases where you have a view object that, you know, you maybe want to pop up for a little splash, and then you want it to go away and then come back, you know. So that's when you really want to specify it as strong, if you really want to keep on to it. And I just explained that. So let me just give you a brief example here. So I have this little example here. So I had the progress bar you saw, and the idea was that, you know, let me put in this code that says, okay, if the progress bar is complete, then after 3 seconds, remove it from the superview, right? And right now, this progress view is, let's see, it is defined as weak right now. So my outlet is defined as weak. So let's see what happens. So progress bar is counting up to 100%, and that's 100%, and then now, you know, it's going to disappear. But then I'm going to hit repeat so it can come back, right? So reload, I want it to come back. Well, it didn't come back. So let's figure out why it didn't come back. I mean, we already know, but just to walk through this. So let's go here, right? Let's go to the case where, let's actually put a breakpoint here. And let's see here, let's hit repeat again. Okay. So let's see, we'll print out. So if you guys don't know, to print an object, you use PO, which stands for print object. And then you can actually print out the properties of this object. So let's see what our progress view is. It's nil.
Is that in the debug mode? Are you in debug right now?
I'm in debug, yeah.
Oh, cool.
So I just hit a breakpoint, and I was just, you know, printing out the object, and that's nil. Let me print out the label view. HTML2. Well, what happened was I actually removed this object from the super view. So now that the super view doesn't have a retain on it, it's free to go, right? And that's when I say, okay, I kind of want to keep that guy around, so I'm going to make that strong. Okay, so I'm going to rerun this. All right, so let it load up.
Predicates.
It disappeared. Let's hit repeat. So came back. So the idea is that, you know, it's doing what I wanted to do now.
So if you have a pop-up screen that you just wanted to capture information, capture information like a need to do or whatever, is it okay to leave the IDO, the outlets on there?
Yeah.
Weak in that case, because the screen is going to go away at some time and it'll come back.
If you expect it to go away when they hit dismiss, then it's okay to keep it as weak. Because you don't want to keep it around.
Yeah.
But a lot of the cases for pop-ups, it's usually there's some subview that has a pop-up that displays information, and then you want it to go away, but then when you click on something else, you want it to pop back up with some new information. So that's why I usually keep it strong, because it's it goes away for a little bit, animates in, does its thing, animates out. You want to get it out of the view stack, but you may want to keep it for when you want to bring it back later. So that's
Is it
kind of
only until the scope of the variable defined?
Say again?
So the weak is,
Oh,
defined as a scope outside of its calling method or something?
Yeah, so when you're declaring,
So as long as the containing class or module that is in scope, it will
Yeah.
retain it, right?
exactly. So as long as this main view controller is around, it'll retain that object. And I am definitely sure that when this main view controller goes away, it will release that object too. So you won't have to worry about some retain cycle or something like that. So it does get released automatically if the container that has a reference to it gets
This goes out of
released.
scope.
Yeah.
So the memory is released from that, correct?
Yes.
And I noticed on the Swift side, you got this, you have a reference to self prefixed on, like functions and.
Yes.
What's your recommendation on when to do that?
Well, that's a good question. So this is also just from history. I've always used self. It was just kind of how I was taught as far as from Objective-C days. You're always using self and never actually accessing the variable directly. And the main reasons are, it's kind of obscure now, but the main reasons were sometimes you may implement a getter that changes the value of what you're fetching dynamically, maybe based on, maybe you fetch it at one time, it gives you this, fetch it at a different time, it gives you that. So that's why it was easier just to call self dot, give me that object. Because then if you wanted to later override and say, oh, instead of giving you that object, I'm going to give you another object. You already have all your other functions using the self dot to access it. In Swift, I haven't really captured as far as like when is the best behavior, because in Swift a lot of the variables you can actually define lazy loading for variables. So like some variables you wanted it to load with certain values when you initially accessed it. So I think I have a lazy variable here in some. Yeah, so my video players object, it's an array of view controllers. So I lazy loaded by basically saying, okay, the idea is anytime, like basically the first time I call self.video players, it's basically going to call this function and say, create me an array of view controllers and then return that. And then every time every time I actually set video players to nil, and then call this get again, it's actually going to recall this thing. So lazy loading means basically don't actually allocate the memory until I really, really want it. So, you know, it's really useful in cases, I mean, this case is kind of simple, but it's useful in cases where you need to do a lot of setup stuff for some object so that you can, you know, allocate it, initialize it, you know, maybe register some properties, and then return it back to whoever needs it. It's a really good way of abstracting things, so basically if you have an app that no one ever calls, you know, video players, then I don't actually allocate that memory. So that's the idea. Let's see.
So lazy is actually a keyword in Swift?
Yeah, lazy is a keyword in Swift. Yeah.
Okay.
I mean, before in Objective-C, what you would do is you would actually override, you know, get video players, and then return back a newly allocated array. Like you would override the getter and return back a new array. But lazy is actually really helpful because it's doing exactly what you want it to do. You load it when you need it, or you don't load it when you don't need it. You know?
So it's kind of like the equivalent of check if it's null, like the way you were talking in Objective-C. Check if it's null, then
Yeah.
you go initialize it, give it in the getter.
Exactly.
Else just don't bother initializing it at all.
Exactly. Yeah. And it's really useful for, you know, for saving on memory. So if I built this into like a framework or something, you don't want to have all these, you know, like initializations allocating all this memory if no one's ever going to call you, you know. So that's the idea of doing lazy loading. So, you know, you're not actually getting your, you know, taking up a lot of memory space. So I guess, was that clear on the strong?
Kind of. I was seeing a lot of syntax. We're both familiar with .NET framework,
okay.
so we're trying to, you know, kind of translate whatever we know into what you're showing here.
Sure.
So the super keyword,
The super keyword.
can you go into that a little bit?
Yeah, sure. Super is the way Objective-C works, and I guess the way iOS works, is that when you are creating your object, it is your superclass or your parent class that actually creates you, and then they actually are the ones that destroy you.
Okay.
So, and it's kind of weird how it's set up, but let me see if I have a.
It's an inheritance that you're talking about, right?
Let's see if I have any functions. I don't have an init function, but the idea is that when you create when you create an init function. So this initializer is. And the reason why it's done, I can only speculate the reasons why, but this is kind of from past history. The reason I think it's done is because when you allocate the memory for the object, it is your parent class that's actually allocating the memory for you, and then they're responsible for initializing it. That's
So
kind of
when
how
you refer
Apple.
self, it's the class itself, and super is the, it's a, you know.
It's a parent class.
Yeah,
Okay.
base
Yeah.
class and the sub.
And you would see this if you were basically subclassing something.
Yeah.
If you were like that's
Derived
why it's
classes.
here. So if you were subclassing view did load, you were in Swift you say I'm overriding this function, and then Apple says when you override a function, it's always best to call super to make sure that the super does what it needs to do, and then you can go ahead and do what you need to do.
Yep.
So in case, you know, if super was doing something where it was releasing memory, allocate memory, doing something, you want to make sure it does its part before you start messing with it. And I mean, there's a ton of, you know, gotchas about, you know, self and super, but that's really kind of the basic premise. I mean, I guess let me just do this actually. So this is a typical initializer for any object that's that you do in Objective-C. And the initializer is basically saying self equals super init. And then you can just return self. So very cryptic, but the general principle is that your parent object's going to initialize, do whatever it needs to do. Then you can do your own initialization, and then you can return. You can now start your day. So that's kind of how it's all based on memory pools and memory allocation, that kind of stuff. That's how it's set up. All right, let's go back to the slide. Let's see. So I'm just going to talk briefly on private versus public. So in Objective-C or in Swift, basically, there's different variable types. There's public, which means it can be accessed by any object. Private, which means you can only access it by instances of the class itself. And then Objective-C, there was protected, which I honestly could say I didn't ever use because no one I've ever seen in any code or sample project ever really used protected. But the idea of protected was that if you had a subclass, you could actually access protected variables of your parent class. But another outside of class could not access that variable. So maybe you had some secret property on a car called steering wheel, and you wanted to access that in your subclass and make it a fancy steering wheel and do that. You can basically do that with protected, but it wasn't available for some other truck or something to access that steering wheel object. So that's kind of the idea. However, protected was the default for Objective-C, but is completely not even existent for Swift. So Swift, they have this thing. So public and private are basically the same for Swift, but they have this thing internal, which means that it basically can be accessed by any object in the module. And in the module really means, it kind of goes back to namespaces and stuff like that. So basically, all of the Swift code that you write is going to be within a certain module. And it's basically called app-whatever module. So the module is just basically a space that allows you to access any classes or objects that are within that module. So it's kind of like a namespace in C, or I think they have that in C#.
Yes.
Yeah. So it's kind of like a namespace, and also internal is the default in Swift. So if you don't actually define something as private, then by default it is internal, which means it basically, I basically consider it as public, but it's public within Swift. So, and then I also gave a little reference here of developers' explanation for why they got rid of protected, which is basically, they were just saying that they didn't really think that having the paradigm where your subclasses could manipulate your parent class's stuff, they didn't really like that paradigm, so they took it out. So that's the reason why they got rid of protected as a type. It's pretty elaborate, a few paragraphs how they explain it, but it's pretty interesting. I'll just give you a quick example. So, can never get out of this. All right. Let's see. So in my class, I have the main view controller. I don't actually have any public properties, mainly because main view controller, no one wants to talk to it, basically. No one needs to talk to it. But in demo, but what in Objective-C, what you would do is to make something private, at least for properties. This is kind of the standard that I've been following. This is kind of almost like a category on your own class, but you do it inside your implementation file. And I know in Apple's template, when you say create a new Objective-C file, typically it actually creates its own little category like this. So it's a category with no names, basically no name for the category. And you can define your properties in here, and these properties are only accessible within the scope of the file. So it's not within the scope of the class, but it's within the scope of the file. So think of it as if I had 5 classes in this file, all 5 classes could still talk to this variable or to this property. So that's a good distinction. However, like I said, it's been a while. I can create a, let's take, let's say, I'm walking through dark territory here. So let me just kind of give you a little explanation. So all I'm doing here is this is a way to actually, so at property is a way to oh yeah, good question.
One quick question.
Sure.
At implementation, right?
Yes,
Is that similar to like a class implementation?
class implementation, yeah. So in Objective-C, there is a header file.h file, which is this guy,
Yeah.
main view controller.h, and then that had at interface. Interface is just like your declaration,
Okay.
declaration, and then implementation is just like the implementation or definition.
Oh, okay.
And then I don't think I'm going to do the private example for this variable because I don't want to say something that I don't like know firsthand. So, but I just want to explain, like, you can actually create variables in different ways. So creating a variable in this way just basically saves some space for this variable. Creating a variable in this way is basically saying create the variable and also create a getter and a setter for it. So if I want to access it publicly or whatever, I can take this here and put it out here and say anyone who wants to talk to my main view controller, call main view controller dot completed count, and you can access my completed count variable. So that it's basically automatically creating a get completed count and a set completed count. And if you go through the compiler, you actually will see it like that. And what's really crazy is that in Swift, if you want to actually expose, if you want to expose Swift properties or Swift variables to Objective-C, you actually just have to put at Objective-C.
Yeah.
You put that around your class, and I think it's just saying that. I think it's saying I need to create a module header. Bridging header, yeah. So it's saying I need a bridging header. But what happens is, it's funny, sometimes when I stop the compile, like halfway through, it's doing its Swift thing, it'll actually show me the output. It actually converts the Swift code into Objective-C code so that it can be accessible by Objective-C code. And it's really funny. So if there was a variable here, it would actually create the getter and the setters and everything for Objective-C so it can be accessed that way. So yeah, let me go I'll talk a little bit more about private public. The singleton model,
John, quick question before.
Sure.
So you talk about public and private, right? And in Swift, what exactly do we, what's the syntax for public and private in Swift? How do you make a variable? Do you actually call it public?
oh, in Swift?
Yeah. 'Cause I don't really care about Objective-C, I'm just kidding.
I understand,
You're not
I
kidding.
understand.
No, I'm not kidding, no, I'm not kidding. But I don't want to say No, I come from Java background, so for me it's like Objective-C is the thing of the past. But the reason why I asked you is last year, remember we were talking about passing references of master view controller to the child view, like whatever
Yeah.
controller, detail view controllers,
Yeah.
where we were passing stuff for the grocery app. One of the suggestions was pass the object itself at this, and then
Sure.
give it to them, and then they'll give it back to you.
I'll get it
I
back.
found, and after I started working in Swift, I figured out there's another hacky way where you could go take any variable that you want it to be available across all your controllers, detail 1, detail 2,
Sure,
detail 3,
sure.
put it outside your master view controller,
Yeah,
like almost like a global variable.
it's a global variable, yeah.
Does that fit into your public and private, or is it completely outside your?
Yes, it does. I believe you can put a public declaration on a class,
Okay.
and then I believe everything inside of that will be public to whoever,
Okay.
to anybody
And
who
if I
wants to
put-
access it.
If I put something in line 35 outside of your master view controller, I just call it, yeah,
Have a var counter.
that counter is accessible for every instance of anything I have in my project.
Yeah,
Is that a good thing? Is it a bad thing? What's your take on it?
that's a good question.
I use this hack a lot in my code, and I figured
It's
out.
probably bad.
Right.
The reason why I say it's bad is mainly because the variable is exposed.
It's exposed, and it's
Yeah.
not heavy. I don't put like objects in it. It's mostly flags.
Oh, flags.
Did somebody upgrade my app? Did somebody not?
Yeah,
upgrade
and that kind of actually goes back to what I was about to talk with the singleton model.
it? Okay.
It's basically wrapping your flags in an object, so that your object has memory control. Because
Okay.
once you declare a flag in public space, it takes up memory forever.
Okay.
Through the life of the app, because it's global, it has to be there, because anybody can access it. The other reason is that it's not thread safe. I mean, if you had multiple threads doing something, they're checking that flag and reading that flag and writing to that flag, who knows what could happen because it's not thread safe. Two things may be writing two different values of the flag, and it won't stay in sync. That's a whole nother story about it. Like properties in themselves, you could call set property from any thread that you want to, but you also have to make sure that it's thread safe if you're trying to do it for multiple threads. So there's certain things, that's the whole idea of this on non-atomic and atomic stuff. It's basically saying non-atomic, which is, it's so funny, like I'm so programmed to put non-atomic there that you almost forget like why you're putting it there. But non-atomic really means that it's not thread safe, basically. That means when you set it, when you set it on one thread, the other thread may or may not get that same value. So which is crazy because if you didn't put non-atomic, Apple defaults it to atomic. And the only thing different between atomic and non-atomic is that with atomic, it actually adds a whole bunch of like encapsulation for synchronizing it across threads. You may see a performance hit if you're doing some kind of crazy stuff on this object, but by default, if you didn't specify non-atomic here, it would default to atomic. Now, don't ask me exactly what all it does under the hood, but I assume it's basically creating some kind of, lock or something on that object while it's reading and writing to it. So, I hope that answered your question.
No, thank you.
Yeah, I was going to do a little bit more background on the public-private for Swift, but I just didn't get around to doing that one. So the singleton models. So I like singleton models. The pattern is basically you have one instance at all times. It's kind of basically like you have a global flag, you know, out in space somewhere. The idea is that you only have one, so that you're not creating, you know, multiple instances of, you know, something that you're always going to be accessing. Single access point, and then it's also lazy loaded to save memory. That's a key thing, because you may not need to call that object. You may not need whatever that object's doing. You may not need it. So why actually, if you're not going to call it, why allocate memory for it? If this was a global variable, it automatically takes up memory even if you're not going to be using it. So that's the kind of thing. So now, moving to Swift, Apple seems to not really encourage singleton models. Well, I wouldn't say they discourage it, but they kind of made it a little bit more challenging to create one. I'll show you here in a bit. But also, you also have to be careful when you're creating singletons, because I know people that can create a singleton that basically does everything, the whole kitchen sink, right? So you basically say, I have this object that can do everything, and I can call it from anywhere. Well, let me put this in, and let me put that in, let me put that in, let me put that in. And so I say, you know, always think about the specific use case that you want the singleton to do. You know, the example I have is Apple uses NSUser defaults, right? So NSUser defaults is basically you're accessing a little, it's basically like a little plist file, XML file, using defaults. So it's basically an object that you can talk to and store objects onto disk using this mechanism, NSUser defaults. UI application, it's a singleton because it's basically UI application is the one that's launching all the apps on your iPhone or iPad. UI screen, NS file manager. So, I mean, all of these are singleton models that Apple's using or doing. And they're basically built in a way so that you kind of understand what you're getting from it. And so, and they don't really have a ton of you know, functions in the, you know, it's really like NS file managers, give me a file, create a file, give me a file, you know, find the file, that kind of stuff. So they kind of keep it very specific on certain functionality. So if you find yourself having a large number of functions in your singleton object, think about possibly creating, I can't even remember the paradigm. There's some coding paradigm that basically says, you know, create a factory on it. So instead of your object doing all of these functions, maybe your object can create smaller objects that do smaller functions. And so if you say, I need to create, you know, a task manager, it'll basically create a little task object, and that task object will go and do it. It'll just keep a collection of tasks. So the task has all of the junk for what the task needs to do, but the task manager just says, I have an array of tasks. So that's good. This is, again, I'm an Objective-C fan, so this is an Objective-C version of a singleton model. And the idea is you have a static variable, and once the variable is allocated, then that variable stays around forever. And this is using Grand Central Dispatch to create the shared one, and this dispatch once is really just kind of like a way to lock, so that when so if multiple threads try to call shared manager, it doesn't, you know, create 2 or 3 instances because it didn't know that the other guy was doing it. So it's a way to keep things synchronized. Before GCD came out, this was the way that I was doing it, the old school way. And in Objective-C, they have this thing called @synchronized. And @synchronized is a keyword that basically says, put a lock around this object. And then you put in the scope, self. Now, this class is actually, this plus here, it means that it's actually a class method. It's not an instance method. So the cool thing about Objective-C is that you can actually call properties on the class so that the class can actually do things and create things for you without you actually needing an instance of that class. So it's kind of obscure, but it's cool in these kind of cases because you're basically telling the class, hey class, I need a shared manager. And this class is going to create a single instance of that shared manager. So that every time you call class.sharedManager, it's going to return back that same static instance of that variable. And then when you pass it itself, you're actually saying synchronize on the class. So what that means is, like, let's say you had 3 threads calling class.sharedManager. It's actually going to synchronize on, if you're calling the class and it's synchronized on self, the class is going to put a lock around itself, around the class. So you got to be careful because you can actually use that synchronized self in some other getter, right? To say, give me something else, and put synchronized self. It's actually going to synchronize on anywhere you put at synchronize. So no matter what you're getting. So it's useful in both the cases where you're doing something like this for a singleton, and it's also useful when you're trying to access maybe an NS array or a dictionary or something, because dictionaries and arrays are not thread safe. And a lot of people think that they are, but they're actually not. So when you're doing multi-threaded stuff, it's really useful to understand that you might want to put an @synchronize around your getter if you're adding objects to an array or removing objects from an array, and you know that some other thread might be doing the same thing. It's best to put a synchronized block around self so that you know that, okay, if I'm locked on it, I can do whatever I want to, so that when someone else pulls it or updates it, it won't crash, because it will crash if you don't have it thread safe. So this is the Swift example. This is probably the best Swift example I can find. So before, we had basically a static variable. Shared manager. Well, apparently they didn't want classes to have static variables, so they allowed structs to have static instances, static variables. So what this is doing is basically saying, inside my class, I'm going to have a struct that has a static instance. So then when I actually want to access the shared manager object, it's just going to give me the struct.instance. So it's giving me the structured instance. So that is kind of the Swift version of doing the whole singleton model. But it works just the same way.
Significance of the let keyword?
Significance of let keyword, yeah. Let actually means that it's, let me put it together. Let means that it's immutable. Means that you can't mutate it after you set it.
Oh, okay.
And so they used it here because they're only setting it once. So that actually helps keep you from trying to set it multiple times.
How about the lock here? You remember the lock here? Use a synchronous lock here.
Oh, a synchronous? Yeah. I believe, I have to try this out, but I believe that, the synchronized keyword works inside of, inside the Swift language. I believe, it's been a while since I've used it, but I believe that synchronized keyword is also available in Swift.
Maybe because it's immutable, there's no need for it.
That is true, yeah. I mean, a lot of this stuff with let and stuff really keeps things from being mutated more than once, but there's always going to be a need for synchronizing objects between threads and stuff. So, but because Swift has changed so much, I believe they added the synchronize later after like a beta, I think. So, well, we can try it once we get the code. Let's see. Instruments. All right. So instruments helps you debug memory and debug performance issues. So I have never coded an app that didn't have memory or performance issues, especially if it's a good good sized app, you know. There's typically some, you know, issue with memory performance, especially when you're doing things like animation or loading data from a file or from a server. And so it's always good to know how to use instruments. So how many of you guys actually used instruments? Awesome. so I'm gonna be, I'm gonna be the proponent of using instruments. So my thing is always say run instruments, don't run from it. Okay. So I'm gonna give you just a walkthrough of how instruments works within Xcode. So the key is, when I go in here and I have my project open, I'm doing all this stuff here, and I'm ready to basically profile it in instruments, there's a tool here under product, it says profile. And what that's going to do is basically going to build a object, build an app, and then this is very daunting. it's like you kind of get the deer in the headlights, like, what are all these icons, right? So let me tell you my go-to tools. I can't really explain every tool here, but my go-to tools is Leaks, which is basically, it tracks all your allocation for your app. So anytime you say, why is my app running out of memory? Why am I getting all these, memory, didn't receive memory warnings? Why am I getting all that? Well, this Leaks will tell you basically how your memory is being allocated and who's allocating it. And then Time Profiler is the other one. And Time Profiler is really more of like, okay, why is my animation really slow? Or why when I scroll things don't really move fluidly, right? The Time Profiler will tell you what's going on that same thread that's basically blocking your scrolling from happening. And that can kind of help you really understand what, how your app performs. We'll start with the Leaks tool. So the Leaks, when you hit Leaks, it actually creates two different instruments. So all of those different icons, they're actually individual kind of instruments. So it's kind of like you have a library of all these different tools that will access some part of your app or some part of the system to give you information. So inside here, you have allocations tool and the Leaks tool. So allocations is basically just tracking that. It's just tracking every alloc call that you call. So alloc, init, all the alloc inits. And Leaks is indicating, what did you actually forget to release? What happened when maybe your screen went away and you forgot to release some object? It'll basically put a little spike saying, hey, you forgot to release this. So I'm going to hit record. So record is basically saying launch the app and start recording all of the stuff in the tool. So it's going to launch the app, and for some reason it never brings it to the front. So the app is running, and it's loading the videos and doing all that stuff. And you can see here in instruments, you can see here where it's actually allocating memory. Now there is a leak here. I can't remember what it was. Something related to the system. I won't go into trying to debug it, but the idea is that when a leaks happen, you'll see a little bar pop up. And then so like you can select allocations here, or you can select leaks. So allocations is basically showing you all of these allocations. So while the video is playing, it's allocating memory. But it's staying pretty static because the way the video player is optimized, so it keeps the same amount of memory, but it just reloads the data into the same memory space.
Will you be able to attach code to these so it can refer to the code where the actual leak is?
Yeah, sure. I'm going to show you. So in this case, so let's select the leaks tool. Let's try this out here. So select the leaks tool, and it's showing me that there is a leak on this object. It says malloc 16 bytes, and the responsible library is audio toolbox. Let me explain this. something about unowned manager. So this is actually like a system library that is leaking memory. And this could easily just be like, because I'm using the simulator and the simulator is using the Mac system audio libraries to render the audio. So it could just be, you know, something that happened on the simulator and not on the device. So there's a lot of things that, you know, I love using the simulator for you know, debugging and stuff, but there's a lot of things that the simulator can do well that the device can't do well. There's some things that the simulator, everything breaks, but on the device it works fine. So, so it's always good to have both. But the simulator will get you pretty far. So if you click on the little arrow, it actually kind of goes into this whole reference counter. So the delta, I mean the triangle means delta. It's just saying like the reference count delta. So somehow in here there was a reference count of 1, and the delta is +1. So I honestly, I'm not exactly sure why it thinks it's a leak, but it could just be because I'm playing videos. You know. But let's look here at the allocations tool. So the way you actually kind of narrow down what you're looking at is you hold down the, you don't actually hold down any. So you basically, I go into this region down here, and I select a region of, you know, a region of tracking. So what it's doing is basically showing me the memory that was allocated within this time. So you can see this big jump in memory here. If you go in here, there's a few different things that you can look at. The one that I typically use is, call trees. So call trees is actually showing you basically the hierarchy of things getting called. And the big key here is hide system libraries. Hide system libraries basically says, the library is allocating a bunch of stuff, you know, I can't do anything about it, I can't fix that. But if I hide this, I'm only looking at code that I wrote. So that's really helpful. And so this is really cool. You can basically say, okay, and this percentage here is actually useful because if I don't hide system libraries, I see, okay, 127 megabytes have been allocated in this one time block, right? But if you hide system libraries, you realize that your code is only actually allocating 0.3% of that. So the rest of this is basically just allocating the memory pool for the video to play. But you can actually see where that 0.3% is being allocated at. So you can basically drill down and say, okay, update progress view. So if you double tap on this, it'll actually go to the line of code where it's actually allocating the memory. And so this percentage here is actually telling you another hint. It's actually saying this line of code is 62% responsible for this amount of allocation. So if you're looking at your code and you're saying, well, okay, I got 20 lines of code here. Which one is actually doing the biggest chunk of the allocation? It'll say, okay, 62% of my 62% of my allocation is being done right here. And I believe it's just because this is probably the first place I called video players, and video players is where I actually allocated some memory to store. Actually, no, I think this is just basically storing memory for the progress. But let's see, you can actually sometimes it's this case is not that big, but you can actually go and look at across a longer spectrum, a spectrum of time, and see kind of where your code is actually eating up. Let's back up here to this method here. So this gives you a little bit more information here. So it's basically saying, out of whatever memory was being allocated, 1% was here, 5% here, 72% here, in creating player with player item. So a lot of this gets really relevant when you're, it really becomes relevant when you're doing this repeatedly. And let's say if you say, oh, I need to load 20 videos, right? And I'm trying to figure out why does my 20 videos not loading super fast? And you realize, okay, player with player items getting called all these times, but well, maybe I only need one player, so maybe I can call player with player items somewhere else. And then, if I only need to allocate this memory once, sometimes you might see things where you're saying, okay, I'm doing this call allocating memory where I don't actually need to do it so many times. Maybe I only need to allocate player once and then set the player item, one time. So this is very helpful in indicating kind of what your app is doing. Let's go back and actually, let's close this up here. Actually, I wanted to show you something else here. Let me zoom out. So this is just, so when you run it again, so I had stopped, but when you run it again, it actually restarts the timeline. So it actually starts running again and starts tracking your memory again. And typically, if you're doing the same things, it's going to look the same. But most likely, you're going to have scroll views and table views. You're going to be scrolling through lists and going through stuff, and you can see how your memory changes as you navigate through the app. What I wanted to show you is like when I hit repeat, it's actually going to jump down in memory and then start ramping back up again, I believe. And what it's, basically what it shows me is that, okay, if I hit repeat, it's actually releasing all of that memory that I created for those previous videos, and now I'm creating new memory for all these new videos that I created for my new animation. So, if I was smart, I would probably I would not reallocate those videos if they're the same videos, right? But this is basically telling you that the release pool is getting released to a point where I hopefully wouldn't have any memory warnings. So I can hit repeat multiple times, and then actually, I'll probably do another talk on instruments because I think it's very useful, especially when you're on a team of a bunch of people, 5 or 6 people, and everyone's like, we got this bug and we can't figure out what's going on. We're trying to figure out why does this thing not scroll smoothly, right? It's like, okay, it's usually a memory problem, or it's too much time spent doing something problem. So I'm going to show you an example of that in the profiler tool. In the time profiler. So let's run this guy here. So time profiler is a really cool tool, especially when what it's actually showing you is what's actually going on within that chunk of time. So you can see at launch, there's a bunch of stuff happening because, I'm allocating memory, I'm running through for loops, I'm doing a lot of stuff, and it's taking up a lot of time. And also you can see that there's a bunch of all these different things going on here. These are actually different threads that are getting spawned by the video player. The video player spawning a bunch of threads to kind of handle reading in the video and putting it out and rendering it and then sending it up to the screen. And since I got 4 videos, it's doing everything quadrupled, quadrupled in the time. So let me just show you that. That's still going. I hit repeat, just so you can see the difference in time. The cool thing about this is in this tool, you can immediately hit hide system libraries. And so what that's doing is basically saying, hide any methods that is basically run by the system. So anything that has system method, just hide it. So you can actually just look at methods that your code is directly getting called. And then, let's just start with, let's just highlight what happened at launch. So here there's, you know, three or four threads going here. The main thread is saying, okay, view will appear in main view controller. And the time is actually showing, okay, 80% of the time on the main thread was spent in this, or 15% of this main thread was spent inside this view will appear. And you can drill down to see, okay, what is it doing and, you know, view will appear. So really this is really useful when you want to debug table views. Like if you had something where you had some animation and you're like, why is this animation so glitchy or jittery? You run the animation while you have time profile and it'll show you which function or method is actually taking the most time while you're doing that animation. It could be you're reading from a disk to get your images, or you're, you know, trying to do something, you know, that maybe, you know, doing it too often while you're scrolling. So this is really good for helping that. And then just like in the other thing, you can actually hit the arrow or you can double click. It'll open up the code and show you exactly where that time was being spent. So it shows you kind of the same percentage view, basically to say, okay, this percent was, you know, this percentage here is being done here. I think this one's a little bit off because I think I may need to rebuild the app to get it. It looks like it's a little bit off the line, and that usually happens when it's certain blocks are kind of, you know, symbols have been changed around, or code's been changed. But you know, things like this, view with, you know, view.frame, you know, this kind of stuff is basically kind of give you an idea of what's happening and how much percentage of time is being used for it. So it's pretty powerful stuff. So I would suggest you guys play around with instruments. You know,
That screen is so intimidating. Like sometimes I press it by mistake.
yeah, it's definitely intimidating as far as,
many tools.
you know, there's so many buttons and stuff. But you know, what I showed you is basically, you know, 90% of debugging.
Right.
Especially performance issues and memory issues. That's
Is
like,
there anything in that instrumentation panel that tracks overdraw? Like, you know how in the UI you draw stuff on top of stuff?
sure.
And in the Android world, that's a big no. Like if you draw
Yeah.
the same pixel more than 3 times,
Oh yeah.
you want to pay for it, right?
Um,
They have the same thing here.
You know what? I believe they did. Let me see. These are just a library of all the different instruments it had.
Oh my gosh.
It's definitely, yeah, you can get a PhD on this if you wanted to.
There's definitely a shortcut there in
Yeah.
Xcode that triggers this. I see this pop up every time I do something.
Yeah,
And I get scared and I immediately close it. I don't want to.
yeah, I mean, I know like in the simulator, I think in the simulator you can actually kind of look at like your view hierarchies.
Okay.
But I have to look that up. I'm not sure if that's,
Okay.
you know, which instrument does that.
Okay.
But I know that there is one that basically tracks like how many times you call draw rect.
Right.
on a view.
But like in this one, you have
Yeah.
that plain view white background, and then you have all these video tiles. That's
Yeah.
the second redraw, right? And the profile that I'm looking for is like it's gonna it will start overlaying a shade on top of it like this. Yeah, exactly.
Yeah,
How
yeah.
did you get that?
This is in the simulator debug. There's color blended layers. So it's basically saying anything where you know there's a bunch of layers and
Okay.
views and stuff being rendered,
Okay.
it'll actually color them and highlight them. Other things is copied images. I think that's new. Let's see. Off-screen rendered.
Okay.
So that, you know, that kind of,
That's pretty close because
it's pretty close. Yeah, I know that there's another one that actually tracks like draw rect code, you know.
okay.
But I can't remember what it is, if it's an instrument or if it's just something in the debugger.
John,
Yeah.
so in that example, you mentioned that the video plays are strong, right?
Mm-hmm.
So when you do repeat animation, it's again restarting the whole animation again. So again, reload instead of retaining the states.
Yeah.
So why is like because using mention is strong, it has to.
The only reason that it's because I wrote buggy code. I intentionally wrote buggy code so I could show you, the memory thing. But basically, all it's doing is basically, I'm actually setting video players to the same. I'm actually reallocating video players again, which means it's releasing the old array of video players. Yeah.
So you want to be releasing the video players.
Yeah, exactly. And I mean, I can easily, wrap this and say if video players .count, then skip over this chunk of code, and then, just enumerate the existing ones. But, I was just, kind of showing you kind of how the memory gets allocated and released, and how it shows the instruments. So, yeah. All right. I'm just going to go quickly through a few of these things. I just got a few more slides and I'll be done. NSObject, the mother of all objects. So in Objective-C, NSObject is the super of all superclasses. So it's basically the main class that all other classes inherit from. So NSString, NSArray, NS everything. So it all inherits from NSObject. And with that, there are some interesting protocols that can be done with NSObject. A few of them are isEqual. IsEqual is kind of, I don't know if they use that in Swift, but I know in Objective-C, isEqual was a way so that if you created your own subclass, you could define what it means for your class to be equal to some other instance. So if you wanted to say I'm a car and I'm equal to this car because we have the same color, you could say if my car.color equals that car.color, then return equal. So the idea is that it creates some base protocols so that if you wanted to inherit from it and extend it, then it'll be more beneficial to you to do that kind of stuff. This kind of class is something I use a lot, especially when you're, accessing data from an array or something where you don't actually know what's in the array or what's in the dictionary or whatever. A lot of that's kind of not necessary anymore with Swift because Swift, you can basically type, your arrays. You can say this is an array of strings, this is an array of other arrays, whatever. So what's useful in Swift is to say as question mark, which basically tells the compiler to say, well, if this thing is this type of class, then let this thing be assigned to it. And if it's not this type of class, then don't let this thing be assigned to it. So it's a way to do two checks at the same time. You're checking that, is the object nil? And is the object a type of class that I expect it to be? So it's kind of useful in cases where you're reading, you're accessing maybe objects that you may not know what it's going to return. So, so is kind of class is pretty useful. Also, I also use this kind of class as far as like saying, if it's this class, then do A. If it's this other class, do B. If it's this third class, do C. So that's another way to say, hey, depending on what class it is, let's do one of these different functions. So, I won't get into method swizzling today, but it's basically the concept of swizzling is just taking the class or some base class like NSObject or whatever and overriding its inherent functions. It's not really like, it's kind of taboo in Apple sense. They don't really want you doing it, but I know a lot of people do that in order to create functionality in a base class like NSArray or something, so that because a lot of things is you can actually swizzle a method that NSArray calls all the time to see who's calling that method. You could say, okay, I'm going to swizzle NSArray add objects, and then in add objects you say, I'm going to put a breakpoint to see who's calling add objects on this array. You know, you can use it for debugging. Some people use it for malicious stuff, you know, doing kind of weird bad things to the system. So just to let you know that it's there, it's available. You know, it's kind of one of those clever things that hackers mess around with. But anyway, I won't go into much detail of that.
One question on the copy
Don't
though.
expose your
I'm
hacker
skeptic.
background.
Huh? Yeah. What did you say?
No, the copy method, does it do
Oh.
a shallow copy? I mean, in the sense, only the schema or the structure gets copied, or the value also gets copied?
It's the copy actually. It's usually shallow. Like for most of the classes, it's basically you're like for NSArray, you're basically just copying the pointer to the object. You're not actually creating a whole new object. So like an array, you're creating a new array, but all the objects in the array is just a reference to the objects in the old array. So if you have a mutable object inside of an array and you mutate it in your first one, then it'll mutate in your second one. So that's
And
one of
vice
those.
versa.
Huh?
And vice versa.
And vice versa, yeah.
So
And
even
the
the
same
values
with-
get copied. So that
Yeah, the
makes-
same with dictionaries too. It's like if you have mutable objects in it, then when you copy it, it's only going to copy the pointer to it. It's not actually going to make a full copy of the object inside of it. And it does require you supporting that protocol. If you're subclassing something and you wanted to create a copy, implementation, there's certain methods in the copying protocol that you need to set in order to make sure that you're actually copying the object properly. So it's really useful in a case where you really have these small structures that you want to just copy and put it somewhere, copy, move it somewhere. So, but it does require implementing a certain set of functions in the subclass. And then object can be extended. So that was kind of the idea I was showing, like in a string category or extension. You actually can extend what NSString does or what NSArray does, or you can extend your own classes if you want to, abstract it that way. And I suggest that you do extensions or categories just because it actually helps when you want to use it down the road, because a lot of these extensions and stuff are so useful that you end up saying, oh man, I remember making a little wrapper to get some property from a string, and I can just get it from somewhere else. So I'll just go briefly. Collection classes, we kind of went over most of them, but there's also NSSet, which is basically like it's a collection class that's kind of unordered. There is an NSOrdered set, but you can actually do different manipulations on the set versus the array. It's kind of, they're very similar collection classes, but NSArray is really unique towards ordering. I think let's see. Yeah, okay. I just got a few more slides. So then as far as collection classes, the key thing is enumeration. So a lot of the dictionary arrays, they have some way that you can enumerate through the keys, the values within that collection. In Swift, there are these concepts of higher order functions that you can do on like array and stuff, like filter, map, reduce. I haven't done a lot of it, so I can't really go into much detail as far as how it all works, but it's definitely something to read up on because it really makes code smaller, simpler. So filter is really good. So if you want to like find certain objects out of an array or something, and then I always suggest that you validate your content in the collection before you use it. So always validate that if you're pulling stuff out of an array, make sure to validate that it's what you thought it was going to be. So if you're if you're pulling out an array, and array is like any object, an array of any object, make sure that your any object is going to convert to the object that you expected it to be. If you think it was going to be a string, make sure you pass it, check that it's a string. So that's just something I recommend. This is another thing. This is just an Objective-C example about validation logic. So in dictionary, they have object for key. That was kind of the big thing: object for key, value for key. you know, in Objective-C 2.0, they came up with these things where you can just say dict and then open bracket key. That's the same as saying object for key. So, all right. So last thing is just a few tips, kind of prevent headaches later. You know, I always say, you know, create new objects so that you don't have a lot of bulky spaghetti code in your classes. So if you see your class is getting to be 800,000 lines of code, it's probably time to refactor and start, you know, thinking about what specific things, because you usually have functions that don't really depend on anything. It's just in that class because you just put it there. So think about maybe abstracting it to maybe a category or a singleton, or extracting it to you know, maybe a new class that can actually do all of those specific functions. So that's, you know, one way to kind of clean it up. Also, use blocks and closures in place of delegates. So instead of having this thing where it's like, I got a reference to you and you got a reference to me, so when I'm done with something, I'm going to talk to you and you're going to talk back to me. Use blocks and closures because it keeps things self-contained. So that when you're actually, you know, saying, oh, I'm going to do this and I'm going to tell you when I'm done, do it within the scope of the function that said do it, right? So do it within that scope to keep it contained. Definitely use categories and extensions as often as possible, just because a lot of those categories and extensions that you create, you end up using many, many apps down the line. So it's very useful. And usually, and it's best to put them in separate files so that you're not, you know, having to go and say, oh, I had it in this file, but then I copied it over to this file. And, you know, so it's best to keep your categories and extensions in separate files so that you can always just take the file and drag it over to another project. And then comment as much as possible. That's, you know, something I need to do more as well. And then run instruments, don't run from instruments. So I'll probably do another talk about instruments tools, you know, later on, but definitely explore and try to use it for debugging. Here's just a list of a bunch of references, websites that I, you know, kind of got my information from. I use a lot from Ray Wenderlich. He does like a whole bunch of tutorials on Swift, Objective-C, and a whole slew of different programming examples. And he has a lot of stuff on, you can download sample projects and run it and see how it works. So it's really useful.
Are his tutorials mostly for intermediate and advanced?
He actually has beginner, intermediate, and advanced. He actually has like a full, you know, suite of lesson plans if you want to go through that too. Like, you know, from beginner, like don't know anything about coding, you know, to advanced. So it's really good. And it's not just him; it's the whole team he has that actually contributes to his blog page. And then Stack Overflow is kind of like my go-to place for anything. You know, if I find a bug, I just Google it.
I think
Usually Stack Overflow is the first thing that pops up. I think that's the same for any language now, right? It's definitely, it's awesome. So, all right, any questions, anything?
One on,
Sorry.
Sure.
is the string, NS string, is it a mutable string or does it, you know?
In Objective-C, NS string is not mutable. It is not mutable, it's immutable. So when you set string equals some string,
so when you append, does it create two different new objects? When you append one string with another string, so does it create new objects?
So they have an NS, what do you call it? NS mutable string, which which has an append function.
Oh.
So there's NS string and NS mutable string.
So NS
I think
string is
in
non-mutable.
Swift they just have string, and string by default is mutable,
Okay.
unless you use the let keyword, then it's not. So if you're going to Swift, then string you can go and manipulate it. You can append. You can just do string something plus another string, and that's the same as doing append. So that's really useful.
Thank you.
Categories and extensions, is that a Objective-C thing?
Say again?
Categories and extensions.
Extensions is a, let me go back. Extensions is a Swift thing.
Okay.
It's basically the parallel to what Objective-C categories are. So
Okay.
let me do a side by side here, since you can check it out in this code. So here I created NS string category, which basically just says, okay, these are properties of NS string. So if I have an NS string instance, I can call URL value on that. In Swift, it's called extension. string. And so basically I just did this exact same thing, but you can call URL value on a string.
Okay.
It's basically the same thing. So you know, when I can publish this code, you can do the exact same stuff. So, but I would suggest putting this extension in a separate file. I just put it in the same file just for, you know, for reference. But
So
you can you can extend any class that's out there.
when you say separate file, you mean something.
Yeah,
That's
usually-
why she got Swift or something.
Yeah, usually, you know, like for these in a string classes, like I actually have a class, I actually didn't even go into it, but I created NSObject plus delay block. That was the one where you see perform block of code after delay. So this is an extension on NSObject. So any object that I create, it could be a string, it could be an array, it could be a dictionary. I could say, hey, dictionary, perform this method after a delay. Or hey, you know, string, perform this function after a delay. And any NSObject can actually, you know, implement this method or use this method.
Now, in the Swift example, you have your extension string. URL value is not a function of string, is it?
It's not a function of
It's
string.
your
It's
function.
my extension of
Okay, so
that string class.
You can't override something that's already there using extensions, can you?
You cannot override it, no.
Okay.
The compiler will complain.
Okay.
Yeah, and I haven't played around with this, but I know in Objective-C and categories, you can actually allocate memory inside of, you can't, when I say allocate memory, you can't create new variables in your category or in your, and extensions, there may be a little bit of room there, you might be able to put like a struct or something inside of an extension, but I think a lot of the stuff has to be wrapped inside of a function. So extensions are really basically to extend the functionality, not really to extend the properties of a class. So, but in Objective-C, there were a few, I wish I don't have an example here, but in Objective-C there is some lower level stuff that allows you to kind of do some C-level abstraction. If you wanted to have your own little property for a class, you can actually create a property, but it requires some lower level C code to make it work. And you know, I'm more familiar with Objective-C, and so I know a little bit more about how all these little hacks and stuff that people do. In Swift, I don't even know the half of what's going on, because I mean they're changing it all the time, and you know, I'm trying to keep up. So, but you know, here's also this is my default category. I mean, I drag this from project to project for swizzling code.
S-E-L?
SWIZZLE, swizzle.
No, it's that S-E-L.
Oh, SEL, yeah. That's short for selector.
Okay.
Selector is really basically a wrapper around a method declaration.
Oh, okay.
Yeah, it's kind of the same as passing a function to a function, but you have to wrap it in this whole selector object. It's kind of weird. But what I was going to say is that this actually uses this Objective-C runtime and calls these like lower level C functions. And this is kind of how swizzling works. You're basically saying, replace this default selector, or replace this default method that this thing used to run, and call my custom one. And so I'll probably do another talk on that if anybody's interested. But at least you got some sample code of how it works. But.
So you'll be coming back this year?
Oh yeah, yeah.
This is the first time I've been to one of these.
Oh really? Yeah. Yeah.
We just got
So-
the notification this
So
morning.
yeah, I guess I'll give an introduction.
He lives
He's
the host.
Yeah. So I'm one of the co-hosts here. James started this project. This is James right here. He kind of let me take over today. But James started this whole meetup group, and I joined probably back around August, I think. It's pretty, just a few months ago. And I think we were meeting over at La Madeleine, just down the street, and it was a super small place. And Anthony and I, we work at Verizon here in this office, and so we were kind of like, man, we got to figure out a way to get this meetup at Verizon. I know Verizon is definitely on board with having stuff that's good for the community. So basically, I figured out who to talk to get security on board and get get the room reserved and everything, and so that's kind of how we moved it to here.
So
We've
this
only
is
had it here-
strictly for iOS then? There are no other discussions that go on for, any other languages?
At least not at this, not for this meetup. This
Okay.
is iOS.
Yes.
At this point, yeah.
More focus on.
James is thinking about French.
Now, didn't we start Now, didn't we start out with only Swift, or did we just start as iOS?
When I came aboard, I don't know if you and I came aboard around
So
the same time.
It was
But
it
it
just
was-
iOS back?
It was just Objective-C.
Objective-C, right.
Yeah.
And then
Yeah.
when WWDC came, and then we jumped.
Everybody was on
Yeah.
Swift, so
Right.
yeah, so I'm kind of the last reluctant person to switch over to Swift completely. So that's why, I still have a bunch of Objective-C
I
code.
see
I'm
it, I
like,
see it.
Objective-C, that's my
It's
nature.
on the
So,
screen.
yeah. Objective-C, that's kind of, that's
Now,
where
I'm
I'm
with
comfortable.
you,
But,
You know the history.
I'm learning Swift as I go, so.
John, we can tell. Now, did you have any problem with the last time you upgraded your Xcode?
Xcode 6.3?
Xcode, yeah, 6.3.
Oh, yeah.
You
So,
did?
so there's a big bug in Xcode 6.3, and
Okay,
it's actually related to IB designable.
okay,
And what it does is that there's a thing called IB designable, which is awesome when they brought it out in Xcode 6, but then it's terrible now because it crashes the whole Xcode
is
now.
that right?
But
Okay.
basically, you can put a flag around one of your UI view classes, and you can extend. You can basically, there's this thing here called the storyboard, right? And the storyboard is just it's where you basically design your view. And what you could do is you could actually put extra properties in this section here by putting IB inspectable, IB designable. So IB means interface builder, which is what this tool is. This is kind of like an integrated app in the Xcode. But what it was doing, it was basically, it would allow you to say, oh, I wanted to add a new property on my label called, special color. I could add that property on my label subclass, and then put IB inspectable, and it would show up as a property. And you could actually set it like you would set this, I want to set the color, you could actually set it just like that. And it was very awesome when they brought it out, because it was one of those things where it's kind of like, you always wanted to do that, you always want to be able to extend your view properties and visualize it before you actually hit run. You want to see what happens if I change the color from gray to dark gray, You don't want to have to go and say, set this to dark gray and hit build and run, So they brought out IB inspectable. However, there's a bug in Xcode 6.3, and I believe I've written a report, and another coworker's written a bug report on it. But it basically says, if anytime you see IB inspectable, halt and crash and don't do it. It basically freezes the whole Xcode, so it's pretty horrible. So I basically had to go back through all my projects and comment out the IB inspectable.
So they didn't give, how when you go to view, I think it's view code,
Mhm.
what is it called? I forget what
Yeah, automatically refresh. This
No,
one?
if you go into the view menu,
Oh, view.
yeah,
This one?
there is no, not there. There is an option, I think it's edit, try edit,
Yeah, it's that thing you were talking
edit,
about.
convert,
Yeah, you fix the issues.
yeah, convert the latest, this one is Swift syntax, that was
Yeah.
lifesaver for me.
Yeah, say again?
That first option,
Yeah.
to latest Swift syntax, after
Oh, yeah, sorry.
after
Yes.
I upgraded to 6.3, my same project had like 255 edits.
Yeah. Wow.
Yeah,
I didn't know
because,
that
That
you
sounds
know,
like Swift.
Yeah.
Swift.
So what happened? Yeah. So what happens is Apple, when they release iOS 8.3, or they introduced Swift 1.2, which basically was, they basically redefined the rules, which Apple can do because they're the bosses. And they said that certain things that you assumed was automatically getting, I don't even know what they call, like
Optional versus.
yeah, optional versus,
Right.
yeah, exactly. So
It was mostly out of my ass.
yeah, everything that was like as,
Yeah.
you had to put as exclamation point, or if
Right.
everything,
Question mark.
or as question mark. And so that's what that whole syntax thing would do, it basically convert it to that.
It's like they're writing a language as we're writing code. It's like,
Yeah.
It's just
amazing.
It's
And-
They just woke up one day and said, oh, we got
And I only see it as a show of force by Apple to say, hey, we're changing the rules, you better roll with us, or you know,
That was
you either roll
something.
with us or you don't, you know.
Right, and I like that they gave a nice little option there.
Well,
because-
as you can see, they kind of put a bunch of junk in here, right? Because a lot of this stuff is just historical,
That's
right?
why they call it
So
Swift.
convert to modern Objective-C syntax,
You gotta
right?
be swift.
This is something from
It's like a
Xcode.
flag.
Yeah, it's something from
What's
Xcode
coming
5.2, right? Where they said,
What does
we're
it even
switching
mean?
to this new
There's
syntax.
modern
Right,
Objective-C.
Yeah.
Modern, like Windows modern?
Yeah, exactly.
Now, so your IB designable or IB inspectable problem, you couldn't fix it with one of those tools there?
Oh, no, it was something related to Xcode IDE problem. It's
Okay.
a system related. Basically, I don't know what it was
You're on
doing.
your own.
Yeah, but when you open up a storyboard file and try to go back to
Okay.
a normal Swift file or whatever, it would just hang. So I don't know if you guys have seen that, but I saw it immediately once I started
When
opening up the whole
was
project. Huh?
when was 16 released?
I think it was March
When
9th.
iOS 8.3 got released, it was
March 9th. I think.
yeah, it's
Yeah.
just a
So
month
this
ago.
has been almost 2 months and it's still not fixed.
It's still not fixed, yeah.
No.
Because they already have an 8.4, beta, right?
Yes.
It's not fixed enough.
Yes, it's
either,
out.
from what I heard. I haven't tried it myself, but
Maybe it was-
from what I heard on Stack Overflow, which is, the grapevine. So yeah, but I really would like to get that fixed because I like that tool. The other thing that I liked was this thing here, debug view hierarchy, where basically you could hit,
Interesting. Auto runs Keynote.
it was auto crash. Yeah, that's basically how it was for me. It's called auto crash. So, and basically what it does, it kind of shows all the different layers, the view layers. So you can actually rotate it in 3D and see how your views are overlapping other views. It's really good when you're saying, I know this view's in this view somewhere, where is it? And you find out it's like way off screen somewhere. That can help you debug your hierarchy of views. However, Xcode has a bug, at least on my machine. On my old machine, I had a 2009 MacBook up until last week, and on my old 2009 MacBook Pro, it would kernel pan. Yeah. So I would hit this one little button. I hit this one little button debug, and now all of a sudden you see like the little matrix screen, like just some blank text that said kernel pan. And I was like, what the heck, So, I always, well, I wouldn't say always. Since probably 3 or 4 months ago, I've been posting bug reports to Apple's radar system, just because what happens is they don't actually look at issues unless multiple people complain about it. And so, sometimes even if they say, they're gonna file it as duplicate, I refile it again and say, hey, have you fixed this yet? That kind of stuff. It's just because it's, I still probably got 3 or 4 radars that they haven't even looked at, so. But I started doing radars, and what I usually do, man, I'm pretty picky about it. Like if it's an iOS thing, I'll actually screen record what I'm doing to reproduce the issue. Or if it's something with Xcode, I'll screen grab it so they can actually get a video of what's happening. And you can upload the video to their radar system so they can actually see visually what's going wrong. So I'm hoping that helps, but it can be futile. But yeah, any other questions?
No, thank you.
Awesome, man. Thank you guys for coming out. Yeah, so I was just gonna say, I've been here at Verizon for just 3 years, and this is probably the first time I've given a talk in, I don't know, eight or so years. So this is really cool for me. So hopefully you'll see more of me up here on stage, giving talks about stuff. Did you guys think it was okay? You guys?
It was awesome.
Yeah,
For first time?
So when is that gonna be available?
Yeah, I'm gonna post it. Hopefully, if not tonight, tomorrow. I'm gonna get the code, post it up on GitHub, and put up the slides. Where can you share the slides? Is there any way to share stuff through Meetup?
The slide share? Is that the one that you
Slide
had
share?
on?
Yeah, I posted it to SlideShare before.
Yeah. Okay.
Other than that, I don't think Meetup has like a specific slide
Yeah.
slot.
Okay. And also, I'm recording the video too, so I'll probably post a video up on YouTube or something that's public to everybody, so everybody can, watch it later if they need to review. I'm gonna watch it now and review and be like, oh man, I can't believe how I talk.
Instant replay.
I can't believe how many owns I said. So, yeah, thanks for coming out, guys. Appreciate it.
You want to do the conference? You want to do the conference?
I'm not, man.
You said you went before, right?
I went last year, yeah. I got a golden ticket last year, man, but this year I was out of luck.
Did you,
I haven't been before.
did you submit for WWDC?
Yeah, did you get a ticket?
No.
Awesome.
You want to know?
Yeah.
Have you've been before?
No.
You
That's
guys
the
left?
first time.
Yeah.
Yeah, just pop right
Lucky dog.
And I don't know if maybe they're trying to find people.
You're
who
one
have-
of the first so far.
We're really second
Yeah.
So,
So, has anyone ever told you you look kind of like some Really? I think if you walked in there with like a black turtleneck and jeans and people would take double takes. You'd be like, yeah, exactly, man. They'd be like, sorry, I gotta
Company,
come here.
company
Or I gotta front row seat next to Yeah,
I wish I'd known. I had a